Okay, we'll continue. Okay.
Okay.
All right. So the next one is number 9. A number is 3 digit. All right. Yeah, 3 digit. When expressed by base number 10, that is 3 digit. So 1 digit, second digit, 3 digit. That is base number 10. Okay. So
Okay.
A is not 0. When n is expressed in base number 9, the digits are reversed. So digits are reversed. CBA when you change it, base number 9. Okay. So
Yeah.
they are equal, right? That's the meaning. Okay, same numbers. When you change the number 7 and 9, the digit is reversed way. Find the middle digit. We're gonna find, okay, value of B.
Okay.
Right. The idea is what we have two different base numbers, 7 and 9. So we're gonna compare this number. We're gonna change it to what base number 10, right?
Uh-huh.
Okay. So base number 10, the first one is what? This is what 7 to 0 is C is okay, but you know that A, B, C, they are both what? A, B, C, they are all less than 7, right? This is
Yeah.
also 9, but this is also 7. Same digit is gonna be less than 7. Okay, it can be, right, the number equal to base number or greater than base number. It can be, okay? So the first
Okay.
one is what 7 to the 0, that is okay. That is 7 to the 1. This is 7 square, right? Okay. So first one, ABC is what? 7 square 49. So 49 times A. That's a 10-digit number. And the 7 times B, 7B. Last digit is C. That is the base 10 number. It is okay? You know how to
Okay.
change, right? Okay.
Yeah.
Now base number 9. This is 9 square. This is 9 to the 1, 9 to the 0. Okay?
Uh-huh.
90 square is 81. First number is C, so 81 times C, and 9 times B, and A, right? That must be equals, all right? Okay. Now, how can you find this one? First, check it out. All right, 49A. This is A, and A is 48A, and equals. So this number is big. Maybe you can try. Minus C is what? 80C is okay. So minus 7B minus 7B equals 2B.
Okay.
It's okay? Yeah, 2B. Now let's express why we're gonna find the B. Okay, what is the B numbers? Take a look. B numbers we can divide by 2, right? This is 2, this is 40, this is 24. So actually B equals to 24A minus 40C, right? Okay, now let's find a little more narrow searching area, okay? This one it will be what is that? Common factor is 8. So 8 is out. It's gonna be inside is 8 minus 5C. That is the value B. Okay?
Okay.
Alright. So what is value B over here? I'm gonna write this one. We have this one. B equals what? A times A minus 5C. What is this one? Can you find something from here about the number of B? This number of B is about multiple of 8. It's okay?
Yeah.
You know that B is a multiple of 8. So, to have a multiple of 8, maybe the first one B can be what? 0, right? It's okay?
Yeah.
Or the next one is B is 8. The next is B is 16. Keep going a lot. But there's just some restriction there. The value of B should be less than 7. But this is 8. Is not less than 7. This is wrong. B is not working. Always this number is only one number less than 7. Alright? So B equals to what? 0. B equals to 0.
Okay.
Okay? Now from here, this is 0. This one should be equal to 0, right? So you can find the A equals 5C, isn't it?
Mm-hmm.
So maybe this one is, what is that? They said 3-digit. No, 3-digit number, so A cannot be 0, right? C cannot be 0. We know that 3-digit number, this one cannot be 0, this one cannot be 0, right? So the only thing is what C is 1, A is 5, isn't it? C is 2, A is 10, but this is more than 7, that is not working, right? Yeah, from here we can find all digit number. A is 5, B is 0, C is what? 1, isn't it?
Yeah.
Okay, that's the number, but we're gonna find this number only, okay? So B is 0, right?
Okay.
So the number actually we can prove here, 7, base number 7 is about 501, base number 7, that is exactly equals what? 105, base number 9, okay?
Okay.
That's true. Very good. That is number 8. Number 9, I'm sorry. Number 10. Now we have base number 10. A number n has 3 digits. When expressed by base number 4. Also 3 digits in base number 10. How many numbers of n? But this is 3-digit number. Okay. We don't. Oh no, that is not 3-digit number. We don't know this number, right? When you express this one base number 4, that is a 3-digit. So we're gonna use a 3-digit number. 1, 2, 3-digit number in base number 4, and also what? 1, 2, 3-digit number in base number 7. But we start with this number. We don't know this any numbers, right? Any numbers. Okay, we start from 0. How many numbers are there? 3-digit, 3-digit. It can be infinite, right? Because when you have a very big number, this can be number maybe 4-digit or 5-digit. Okay, all right. So it's not gonna. It's gonna be some limit value there. So how can you find this one? How can you express 3-digit number? We're gonna find all possible number of 3-digit in base number 4, right? That's the idea, isn't it? We're gonna find all 3-digit for base numbers. Where is it? Changing to base number 10. Smallest 3-digit number, what is that? 1, 0, 0. 4, base number 4. That is the smallest one, 3-digit number, base 4 number, right? What is the largest one? 3, 3, 3 is the largest one, 3-digit number in base number 4, right?
Yeah.
It's okay because what? This number cannot be equals to 4, right? Yeah. So base number 4, 3-digit number is what? Has the range like this. Okay, now base number 10 also 1, 0, 0, 7. That's the smallest 3-digit in base number 10. Largest one will be 666, base number 10. That is the largest numbers. So we're gonna find all the number, which is base 10 number, right? When you express base number 4, 3-digit, and also base number 10, also 3-digit number. So we're gonna find this number. From here, base number 4, 100, base number 4 in base number 10. When you change, how much is one? This is the base number. 4 square, 4 to the 1, 4 to the 0, right? So 4 square is 16. That is 16. 2, 0 is nothing. 0 times, or 0. This is 3 to the 4 square. This is 4 to the 1. 4 to the 0 is 1, right? 4 to the square is 16. 3 times 16 plus 4 times 3 plus and another 3. How much is that? 48, 12, 15, 63, right?
Yeah.
Okay. So
66.
60, 48, 63, is it correct? Yeah, 62.
Huh?
63, right?
Wait, but
Okay,
Oh,
I'm
right,
a
and-
little confused, right?
and then you
3
have to add
times
the,
base number 4, right?
you have to add the 3, right?
Yeah, add a 3. 3,
Wouldn't
3,
that
3.
be 66?
66, that is 48 plus 3 times 4 is 12. That is
Oh.
60. Oh, 63 is correct.
Yeah, okay.
So actually from here, 16 to 63 numbers, okay, all these numbers, when you change it to base number 4, they are all 3-digit number.
Uh-huh.
Is it okay? Very good. 3-digit number. But the number also change into what? Base number 7, also 3-digit number. Okay? So out of this one, how many numbers, when you change the base number 10, also 3-digit number, you're gonna find out. Okay, so this smallest number is how much? This is 7 square, 7 to the 1, 7 to the 0, 0. This is 49, it's okay? 7 squared times 1, 49, plus 7 to the 1 times 0, 0, just 49. 49 to the last number. This last number is very big. We don't care about this one. Alright? Any last number is greater than 63, right? But we're gonna find the numbers out of these numbers. Okay? Maybe big number. Or you can just calculate. 6 times 7 square, 6 times 7, and plus 6. That is 49 times 6 is how much? 294, 42 plus 6, that is 342, 342, right? This is up to 342. But this one express what is from here, 49 is up here. Up to 342, very big numbers. Satisfy both, only this one is what? Only this number when you switch into base number 4, 3-digit, also base number 10, also 3-digit only, right?
Yeah.
So we're gonna find these numbers, right? So how many numbers are there?
Between
63
49 and 63.
minus 49 plus 1, right? Or minus
Yeah.
48. This is 14, right? And the 15 numbers.
Okay.
Okay?
Yeah.
Yeah, from 49 to 63 numbers. Okay?
Okay.
Yeah, all these numbers, when you change it to base numbers, they are both have a 3-digit number. Okay? All right.
Okay.
Very good. The next one is number 11. Base number 10, the number 2013 and in the digit 3. Okay? Yeah. 2000, we know that. Yeah, digit 3. And the base number 9, on the other hand, the same number is written, this one is what? And yeah, this is just 6. That's fine. Okay?
Okay.
For how many positive integers b does base number b representations of 2013 up to 2013 and with what? Digit 3. So when you have 2013, but we write this one, okay? When you change this one, base number 9, one of the example, this is gonna be 26 and 76, base number 9, but digit is 1, and with the 6. Okay, now another one. Now we're gonna change this one is base number b, but the digit is what? The digit, something like that, and with 3, right?
Yeah.
But when you have a base number b representations, but b can be what? Greater than 1. There's no base number 1, right? But there is no base number 2 because this is already 3, so this base number b should be what? Greater than 4, isn't it? Yeah, we have, don't forget this one, okay? Yeah. Already this number is greater than these numbers. More greater, we don't know because it depends on all digits. We don't know, right? Okay.
Yeah.
So the last digit is 3.
Okay.
Okay. So question is, how many different base number? Okay, with like the last number digit is 3.
Uh-huh.
So this is a 4 is okay, 5 is okay, 6 is okay, right? This is base number, that's fine. Okay, so what that means, when you have a base number b, remainder is 3, isn't it?
Yeah.
Okay, when you divide by that, this is a kind of what? Modular arithmetic, right? This number 2013, this one should be what? Remainder is 3 when you divide by b, mod b, isn't it?
Mm-hmm.
Okay, we're gonna find the b over here. Okay.
Okay.
So what are these numbers? When you minus 3, minus 3, minus 3, minus 3. So 2010, that is equals to 0 mod b. What is this number there? This number actually, what is that? Factors of 2010, isn't it?
Yeah.
When you divide what 2010 by a factor of these numbers, always the remainder is 0. Okay? But you're gonna find these numbers. So find out the factors. 2010, this one is what? 201 times 10 is 2 times 5. This one is 3 times 67. So this one 2010 can be expressed 2010 actually 2 times 3 times 5 times 67, right? That's true, right?
Yeah.
So how many factors are there? Can you find it? How many factors are there? You know that 2 to the 1, 3 to the 1, 5 to the 1, 6 to the 1. You can add 1 over here, right? 1 plus 1 is 2, another 2, another 1 plus 1 is 2, another 1 plus, there are what? Total number of what? 16 factors there. Okay?
Okay.
But when you factor, you can see that 2, 3, and 5, 67. Always 1, 2, 1, 3, 1, 5, 167, right? That's why we multiply 2 times 2 times 2 times 2. But this factor should be greater than 4. Smallest factor is 1, right?
Yeah.
The next factor is 2, isn't it? 2 times 1, 1, 1. The next factor is 3, right?
Mm-hmm.
So we have, this is all 3 factors is less than 4, isn't it?
Yeah.
Or the other one is what? 5 is greater. That's fine. 2 times 3 is greater than 6. But only these 3 factors is what? Less than 4, right? That is not working. So we're going to take up these 3 numbers. So the answer is what? 16 minus 3 equals what? Only 13 factors. This one can be deserved, right, to be this value of b. It is okay. Maybe you can use 6. The smallest one is 5 is okay. Right? And 6 is okay. The next one is 2 times 5 is 10 is okay. Something like that, right? Okay. There are 13 factors. Okay, we just want to take them out some factors which is less than or equals to 4. Okay? This cannot be the factors. This number of factors should be greater than 4. Is it okay? Alright.
Yeah.
So the answer is what? 13 is the answer. Okay?
Okay.
Alright, the next one is hexadecimal. Yep. Base number 16 numbers written using numeric digits 0 to 9. You know that. 0, 1 to 9. The next to 10, right? This one cannot be 2 digit, right? We cannot use what 2 digit in the place. Instead of 10, we use what A. 11 is what you use B. 12 is C. 13 is what D. 14 is what E. 15 is what D. Up to here, right?
Yeah.
Okay. That's the maximum numbers. Right? So maybe we can use this number 3, 4, we cannot use this 1, 2, so confused. Okay, so instead of using 12, we're going to use C. Okay, and
Okay.
D and 1. That is the base number, 16 numbers. Okay, more
Yeah.
than 10, we're going to use the letter. That's the rule. You can extend it any line, but hexadecimal is up to 15, right? Okay, the digit number cannot be equals to or more than 16. All right. So among the first 1,000 positive integers, there are n whose hexadecimal representation contains only numeric numbers. So we're gonna use what? 1,000. First 1,000, 1 to the what? 1,000. Okay.
Okay.
We have 1,000 numbers out there. Okay, that's fine. Okay, what is the sum of all digits? Okay, there are n whose hexadecimal contains only numeric digit. Okay, numeric digit. What is sum of a digit? So we're gonna find, okay, the maximum number is 1,000. Okay, the maximum number is the minimum number is 1. Okay, when you hexadecimal, okay, 1 is the smallest number, 16, right?
Yeah.
So what is the largest number? Can you find the largest number? 1,000. You can divide it by 16, right?
Uh-huh.
You're gonna find the remainder. When there is 96, 40, and divided by 2, 32, remainder is 4. First number will be 8. That's the remainder, right?
Yeah.
Now find the next number. From here, 62 and divided by 16. 3, 48, remainder is 14. But we cannot use 14. Instead of using 14, we use E, right? So the next number is E. Now you have 3 over here. Okay? 3 is what? Less than 6. Okay, that's the remainder. When you divide it by 16, 33 is the remainder. That is the largest number of our base number 16. Okay, 3, E, 8. Okay?
Yeah.
Okay, now we're gonna find, okay, sum of all digit number. So how many numbers satisfy this one? Only numeric number. So first we can try 3-digit number. This one can be, what is that? 1, 2, 3, right?
Uh-huh.
Only 3 available because this is the maximum number. This one is, what is that? 0, 1, 2, 3, I'm gonna have 9. 10 is what? A, B, C, D, E up to here. That's fine. Okay. The next one, I'm gonna write down the largest number, okay? The next one is what? Number 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's the largest number. When you have a 3 over here, right?
Yeah.
Largest number, it can be E and it can be 8. When you have a 3-digit, the first digit is 3.
Uh-huh.
What is the first digit? 2, it can be any numbers, right?
Yeah.
First digit is 1, it can be any numbers. It doesn't matter. Only what? When you have a first digit 3, second digit is assumed to be up to E, last digit up to 8. It is okay?
Okay.
Alright, now let's find out. When you have a first digit, okay?
Yeah.
So, this 3-digit number, first digit is what? Numeric numbers. First digit only, first digit. Should be numeric number, numeral. Okay, numeral number. So what is this? 0 is now including, okay? Alright, first digit only 1 digit. So what is that? First digit can be, what is that? 1, 2, 3, 4, 5, 6, 7, 8, up to 9 is okay, right?
Yeah.
First digit. This is less than, right? These big numbers. So up to here, how many numbers are there? 9 numbers. Okay, they are all numeral number. Okay, now the next is a second digit, 2 digit. 2 digit over here, from here and here. 2 digit way person cannot be 0 over here. Now we can 2 digit is what 1 up to 9. Is it okay? So it can be first digit is up to 9 is 9 choice. Okay. Now
Okay.
the last digit can be 0 also, right? Now you can be 0, right? 90, 91, something like that, right? So up to 9 is 10 numbers, isn't it? So times 10 numbers, it's gonna be 90 numbers are there. Is it okay?
Yep.
90 numbers. Now 3 digit. First we can try 1. When your person wanted 1, only 1 choice. But second digit is how many choices are there? 1 to 9? No, 0 to 9, right? Because first digit is 1, second digit, right, can be 0. Okay, so 1 to 9 is 10 choice. Another one is 10 choice. They are all numeral number. Okay,
Yeah.
so how much? 100, right? 100 numbers. Is it okay?
Yeah.
100 numbers. Okay. Digit 2 also what? 100 numbers. Is it okay?
Okay.
Digit 3 is also how many numbers? Digit 3 is how many numbers? Also this is okay, 10 numbers available. What about last digit? Up to
8.
8. Isn't it?
Yeah.
Up to 8. So how many numbers are there?
80.
80. No. We include 0, right? Up to 9,
Yeah,
9,
90.
9. This is 90, right? Okay,
Mhm.
90. So 90 numbers. Okay, so total is how much? 9 numbers? 90 numbers? 100, 100, 90. How much is that?
Uh,
3. Let me see. I'm confused. 3 digit, this is correct. Let me see. Last numbers. Yeah, this is true, okay. This is 200, 180, 389, right? Yeah, 389 numbers should be satisfy the conditions. Okay, so the question
Okay.
is the sum of both digits over n. So we're gonna add all this one. 3 plus 8 plus 9. Okay, how much this one?
Yeah.
11 and plus 9 is what? 20 is the answer. Okay.
Yeah.
This is we said casework. Okay,
Uh-huh.
casework. All right, the last number 13. Base 10 3-digit number n is selected at random. Which of the following is closest to probability? The base number 10 9 representation and base number 11 representation of a number n are both what? 3-digit numbers. Same as before, right? Same as before. When you have a base, we have some number of n, a lot. Okay.
Okay.
But this is only what 3-digit. I'm sorry, a 3-digit number. So we're gonna this number n is 3-digit number is what 0 to 100, smallest to 100, largest to 999 numbers. Okay.
Okay.
So out of these numbers, they are all 3-digit number. This is 3-digit number. Out of these numbers, when you change into base number 3 and 11, both numbers are 3-digit number. So these numbers, base number 9, that is also 3-digit number. The other number, when you change base number 11, also 3-digit numbers. So we're gonna find, okay, how many numbers are possible, right? 3-digit in base number 9 and 11. The smallest base number, 3-digit base number 9 number is 100, okay?
Mm-hmm.
Largest one is what? 800? 88, that is the largest 3-digit number, base number 10, okay? This is number 9, this smallest one, this is the largest one. What about over here? Still same thing. 100 smallest one, base number 11, and 10, base number 10. 10, 10, 10, or you can use the AAA, right? That is the base number 11, that is the largest one. Okay, now let's find in base number 10. Check out. This is 81, isn't it? It's okay?
Yeah.
9 square, 81, all the other is 0. This is how much? 11 square is 121. Okay, now let's find over here. 8 times 9 square and plus 8 times 9 and plus 8. Okay, how much is this one? Okay, 8 is out. 9 square is 81 plus 9 and plus 1. This is 91, right? So how much? 728. Okay, that is the largest number in base number 10 when you change this one. So what that means? When you have 81 to 728, only this number, when you change this one, base number 9, they are all 3-digit number. Is okay? Satisfy this number. The second one is smallest number is 121. What is the largest number? 10 times 11 square, 10 times 11, and plus 10. This is okay, good. Directly we can find. 11 square is 121, 0. This is 110, and plus 10. So 12, 10, 120, 130, 30, right?
Yeah.
1,330. From where 121 over here. 121 over here. When you change this one, they are all 3-digit numbers. But satisfied both, only this number available. 121 to 728. But what is the probability when you choose this number out of in this range? I'm gonna make another one. We got 100 to 999. But this number only what belongs over here 120. I'm gonna do 121 to 728. Okay, the probability to choose this number out of whole thing. How many numbers are there? 999 minus 99 is 900 numbers. Okay, we got the 900 3-digit numbers.
Okay.
But how many numbers are there? Take a 120.
607.
608.
Oh.
Oh no, that's fine. 628. 120 is 607, but we're gonna add 1, right? Okay.
Yeah.
That
Okay.
is 608. That's fine. That probability is this one. So we're gonna find, okay, which is a close number. Close what? This number or this number? We're gonna check it out. 0.54. 68. Definitely raised more than 5. Okay. Looks like a 7. Isn't it? Close what? 0.7. Okay. So the answer is E is correct. It's okay? All right. Very good. The next one is the base number. Okay. Now this base number is very popular, right? AMC questions. Okay. The first we're gonna check it out. When you have base number 10 first, base number 10. How we change right base number 10 when you have right repeating decimals? We're gonna change into fraction because the repeating decimal is a rational number. It is not irrational. So it can be changed because the repeating decimal this is, we know that a rational number. But rational number is what? The number in this form, a over b, which is a fraction. Okay, we can change in fraction. Okay, so how we change the repeating decimal in fraction? For examples, first one is when you have this one, point. I'm going to some number that is better. Okay.
Okay.
This is actually 0.3333, keep going forever. Okay. Now to find a fraction of this repeating decimal, this is class method is what? We take what this is only one number that repeating, right? So we're gonna move right this number, one number to the front. How? Times 10 times, isn't it? 10 times x is what is that? 3 is move to the decimal. Now I'm going to extend this one up here. 3 point, this is 0. 3, 3, 3, 3, keep going. Is it okay? Alright.
Okay.
Now take up this one out. Minus 10x minus x is what? 9x. That is equals to 3. All the other ranges forever. That is 3. So the value of x equals to actually 3 over 9. This is equals to 3 out of 9. That's it.
Okay.
Okay. Now the next one, second one is when you have right two repeating decimals, 0.31. This is what? 0.31, 31, 31. This is two repeating decimal. We're gonna move right 2 digits before the decimal. How can you move this one? Times 100, isn't it? So times 100x. So two numbers can move before up front. That is equals to, extend this one, 31.31, 31, 31. When you subtract 100 minus x minus, I'm going to use 100, 10 square minus 1 x. Is it okay? This is also 10 minus 1, it doesn't matter, okay, same things. That is equals to 31. So the fraction of this repeating decimal will be x equals, what is that? 31 over 99, actually what? 10 square minus 9 equals what? 31 over 99. 2 9s are there. Is it okay?
Okay.
The next one. Sometimes we can find the value of x, which is repeating decimal, using geometric series. You can see that 0.3333. This is actually the 0.33333. Maybe you can separate. The first number is 0.3. Second number is already there. 0.3 times 10 to the 1 over 10, isn't it? The next is 0.3 times 1 over 100. Okay, that you keep going.
Okay.
Okay, this is actually what is that? 1 over 100 is square, right? This is 1 square. The next will be about 0.3 times 1 over 10 to the third power, right? 1,000. So actually this is geometric series. Common ratio is what is that? 1 over 10 or 0.1. First term is what? 0.3, isn't it? So this x value is now, okay, infinite series. Remember, first term over 1 minus r is what? Sum of what? Infinite series of geometric series. Okay, the first term is what? Negative 3.3 over 1 minus 0.1. That is what? 0.3 over 0.9 equals to what? 3 over 9. Same as before, right? Okay, so we have two different ways, but there's some rules there. Already when you have a repeating decimals, the value of x is what? 3 or 1 in base number 10. This
Okay.
one is how much? When you move right 3 digits moved to front, we're gonna multiply wow 1010 to the third power. Is it okay?
Okay.
We just multiply 10 to the third power times x equals what is that? 301 and 301, 301, 301. Okay. But when you subtract this one, it's minus 1, isn't it?
Yeah.
So when you divide by this one, using this number, 301 over here. This base number 10. It's okay? Yeah, that's the formula. Now we have a base number, for examples. I'm gonna use it over here. Just give me a minute, I'm gonna continue. I have some number over here. But this number is what? 3 or 1 and base number 5. Okay. Now
Okay.
we're gonna move right all these 3 numbers, move to the front. How? We multiply what? 1000? No. 5 to the third power, okay?
Okay.
This is the base number. Actually, this is what? Take this base number. Base number B, base number B, what is it? 3 or 1 base number B over base number B to the 3. That's the same number, okay?
Yep.
But this number can be obtained. Moved, 3 digits moved to the front, we multiply, what is that? 5 to the what? Third power, isn't it?
Yeah.
When you multiply 5 to the third power of x, so it looks like this one. 301, 301, 301, right? This also what? It's number 5.
Mm-hmm.
Okay. So from here and minus 1 over 301 base number 5. That's the formula. Is it okay?
Okay.
Alright. One more. When you have a base number 10, I'm going to tell you, oh, we have 2 zeros or 3 zeros. 301 over here. A little trouble. But it doesn't matter. But this is actually what it is. 0.013. Just before, right after decimal, we use formula, okay? But 2
Yep.
zeros you can divide by 100. That's the same thing, isn't it? It's okay?
Yeah.
Alright. So this is, we know that 301 base number 10, 1003 cube minus 1 over 100 is what? We're going to put the 2 more zeros. Is it okay?
Okay.
So actually that is the number is 301 over 900. This 1000 is what? Minus 1 is 9, 3 nines and 2 more zeros. That's the formula, okay? When you have
Okay.
this one is a 0.000 and 3, 1, 2 digit number. This is how much? 31 over, we need a 29 because 100 square, okay? 29,
Okay.
but we add what? 3 more zeros. Alright?
Yep.
Okay, that's it. So, this is very important. You can remember this one. When you have 3-digit numbers, this is actually 3-digit repeating. In base number k, 3 number move to the front, we multiply k to the what? Third power. Okay, so this number is what? X over here, we take a 1 over here. Okay, and all this
Okay.
number remains in the right in fraction, but this still base number k, right?
Yeah.
But this number, now we're gonna change it to what? Base number 10. So how much? 8 times k squared plus b times k and plus b. This is now base number 10. Okay? Now we're
Okay.
gonna have some practice. Number 1, I'm gonna use over here, number 1. What is the value of 0.5 to the what? 7 repeating? the idea, we're gonna one by one, okay? So x equal 0.57 repeating. This is actually 0.5555. So we're gonna move one decimal to the front. We need what? Times 5, isn't it? I'm sorry, times 7, right?
Yeah.
Okay, times 7. So what is that? 7 times x. It's okay? Now
Okay.
this base number 5 is moved to the front. 5, 5, 5, 5, 7. So when you subtract up here, 7x minus 7 minus 1x. That is equals to, this is out, we got only 1, 5, but that is still base number 7. Okay? Now, what is the value of x? 7 minus 1, isn't it?
Yeah.
This is just still less than 5, just a 5, okay? 5 times 7 to 0 is still 5, 5 over 6. Okay? Yeah, that's the answer. Okay, now try number 2. Now we're gonna apply formula, right? We don't have to solve this one every time. Alright, so we already try to use the formula. 0.3245 3-digit repeating. But this one is actually equivalent like this one. 3-digit is what? We multiply 5 to the what? Third power, isn't it?
Yeah.
N minus 1, right? Over this number going to the what? Numerator. But this number still digit 5, isn't it?
Yeah.
Okay, now let's find, okay, base number 10 numbers. But there's no answer. All the numbers is expressed in base number 10. The first number, how much? 3 to the what? 5 square, right? 3 times 5 square. 2 times 5. And 4 times 5 is already 4. That's fine. 5 cubed is what? 125 minus 1. That is 124, right? This is actually how much? 124. Numerator is what? 25 times 3 is 75, plus 10 and plus 4. Okay? So that is 89 over 124 in base number 10. Is okay?
Yeah.
This is the base number 5 expression. This is base number 10 expression. Is it okay?
Okay.
Right.
Yeah.
Alright, number 3. Now we have 2 zeros there. Okay, now let's try this one. 2 zeros. We have 0.00315. 2 zeros. What is this one? 2 zeros. How can you handle this one? First, we can move, right?
Yeah.
Okay. 2 zeros. Move to the left. Okay. What is that?
Okay.
When you move to the left, is what is that? You multiply 5 square, isn't it? Okay. This is the x over here. So 5 square x. That is equals to now 0.31 decimal 5. It's okay.
Okay.
Alright, now let's find this decimal. This is how much? 31.5. Move to the right 2 digit, move to the front. What is that? 5 square, isn't it? N minus 1 over 31, 5. Is it okay?
Okay.
Alright. So what is this one? 31.5 is what? 3 times 5 and plus 1, that is 16, right? That is 25 minus 1, 24. So actually 16 over 24 is what? 2/3, isn't it?
Yeah.
But we're gonna find the value of x. You can divide it by 5 square again, right? So divided by 1 over 25 over here. So the value of x equals 2 over 75 is the answer.
Okay.
Is okay? 2 over
Yeah.
75. Or you can go right directly. You're gonna move right 1, 2, 3, 4 digits to move to the front. 4 digits is about 5 to the 4, isn't it?
Yeah.
And minus what? 1 over here, right? And over what is that? 300, 1, base number 5. That is okay?
Okay.
But this number is still 16. And this is what? 5 to the 4th power is how much? 625, right? And minus 1 is 624, isn't it?
Yeah.
Let me see. 25, 24. But when you divide by that, it's not equal. Let me see what happened. Only 600. Something wrong. Okay, anyway, do this way, okay? By the bottom. Okay? Alright.
Okay.
I'm gonna find out, okay, what is this one? Okay. Alright, the next one, number 4. Well, we're gonna try number 4 here. Number 4 is 0.03014. So move to the 1, 4 here, right? What is this is x equals how much times 4 is what? 4x, okay?
Yeah.
4x equals 0.1301 to the 4. It's fine. Okay. So what are these numbers? Move 3 digits or move to the left, right? How? Multiply 3 to the cube, isn't it? And minus 1 over 301 to the what? Base number 4. This is what? 16. This is 4. This is nothing. 1, right? So 3 times 16 is 48. And plus 4 times 0 is 0. 1 times 1 is 1. That is 49 over. That is 64 minus 1 is 63, right?
Yep.
So that is 49 over 63 is 7 over 9. But you still divided by 4 again, right? So x equals 7 over 9 times 1/4 is what? 7 over 36 is the answer, okay? Alright. Alright, the next one. Try number 5. We're gonna try number 5 there. For some positive integer k, the repeating base number k representation of the fraction is 7 over 5. We got the number over here. 0.23k, base number k, that is equals to 0.2323. Note that is already noted. But that is in fraction because this is repeating decimal in base number, okay? It doesn't have to be always base number 10. Any base number repeating, they are always what? Rational number. That is equals to 7 over 51. Okay, so what is the value of k? We're gonna check it out. First, we move right 2 numbers move to the front. How? We multiply k squared, isn't it?
Yeah.
This is actually what? K squared n minus 1. The number 23 still in numerator, but that is the base number k. That is equals 7 over 51. We have to solve this one. 23 is the base number k, right? Not base number 10, okay? Don't be confused. So this 23 base number k, when you change base number 10, what is that? 2 times k plus 3, isn't it? Times k times k to 0 is 1, right? We multiply these numbers. 2k plus 3 and over k squared minus 1 equals 7 over 51. Now we need to solve this one. Cross multiplication, 7 times k squared, I'm going to do this one. 7k squared and minus 7 equals 2 times between is 102k and plus 3 times 51 is 153. This is a quadratic. We try to factor, right? Because this is AMC. There's no irrational number, okay? K should be what? Integer. That means it can be factorable. So 7k squared minus 102k and minus 160 equals 7k is only one choice, k and 7k, that's it. So how can you factor? 10, 16, right?
Yeah.
Yeah. 16 is over here, 10 is over here, right?
Okay.
This is about negative 112, this is 10, 102, that's fine. But k cannot be negative number, only integer number. Positive number is what? Only k equals 16 is working. Okay, yeah. The answer is what? Base number 60. K equals 60. Okay.
Yep.
Alright, the number 6. The number 6 is same questions. For some value of k, the repeating k represent one pulse. So this we got this one. 0.03 k equals 1 pulse. First we're gonna move, right, 1 0 to the front, okay, times k, isn't it? So this is x. So times k is what? K times x. That equals to 0.3 k. Isn't it? 0.3 k is now how much? Move to the front times k and minus 1 over that number, base k number. It's okay?
Yeah.
Yeah, that is equals to, now what happens? When you divide by x again, so x equals how much? 3k over k minus 1 times 1 over k, 1 over k, okay? That is equals to 1/10. We have to solve this one, okay?
Okay.
Alright, now cross multiplication. K times k is what? K squared n minus k equals 3k times 10 is what? 30k, right?
Yeah.
Alright. Okay, times. Oh, no. Oh. What we do? Oh, I'm sorry. This way, 3 base k number, okay? Base k number. That's why I thought it's weird. Okay. So this is okay. But 3k base number, k number, that's 3, isn't it? Okay?
Yeah.
So this is 3 times 10 is what? 30. Okay? From here we can factor this one. K squared minus k minus 30 equals 0. You can factor, right? Should be factor. Minus 6. K plus 5 equals to 0. K equals 6. K cannot be negative number, okay? The value of k is 6. Okay? Very good. Okay, this is lesson 15. Now we finish this one. And the next one is the divisibility. Divisibility is very important. It's very simple, but actually important. Usually AMC 10 and 12, they're going to use what? These two divisibility. You have to memorize. All the other one is okay. I think you understand everything. You know that, right? I'm going to make it big. Alright, divisible by 2 first, we're gonna go over, okay? Divisible by 2 is if last digit is what? Even number, they are all divisible by 2, that's fine. This is, we know that. Now, divisible by 3, it's same as what divisible by 9, right?
Yeah.
Sum of digit is what? Multiple over 3, that is divisible by 3. But this division by 3 not already divisible by 9, right? Division by 3 is about 3, 6, 9, 12, and 50.
Yeah.
But this is divisible by not 9. Only this is divisible by 9, okay? But it's the same rule, but different numbers. Okay? Yeah. That's fine. So this is the same as what this one. The next one is divisible by 4. Is we know that 100 always was 0 mod 4, right? When you divide by up to 100, always divisible by 4. We don't check hundreds, just last 2 digits, isn't it? 4500 divisible by 4. We know that 4500. The only things these two numbers is what divisible by 4. That is divisible by 4. Okay, right? That's fine. Last 2 digits. And the next number 5 is divisible by 5. Last digit is 0 or 5. Okay?
Yep.
This is fine. Divisible by 6 is what? Divisible by 2 and 3, not or. It should be divisible by 2 and divisible by 3. That is divisible by 6. And. Okay? Now divisible by is the most popular one, important one. Divisible by 7. Divisible by 7 is what? When you lastly check it out, 672. Twice of this one. Maybe you can use twice. Or 2 times 2. It doesn't matter. Same number. Okay?
Yep.
When you got this number, take off, right? First, the rest of digit. 67 minus 4 is what? 63, isn't it?
Yeah.
But this number 63 is divisible by 7. Okay, this is divisible by 7, alright? So that is what? Divisible by 7.
Mm-hmm.
It is okay?
Okay.
Alright, you have to memorize this one, okay?
Yeah.
The next one is divisible by 10 is okay. 8 is okay too, right? 8 is what? Divisible by 4 is what? 2 digit. Last 2 digit is multiple of 4. Divisible by 4, the number is divisible by 4. But when you have 8, the last 3 digits, because 1000 is what? Always divisible by 8, right? 125, isn't it? So last 3 digits, this last 3 digit is divisible by 8. That is divisible by 8. Okay? Alright. The next one is, last one is divisible by 11. This is very important too. More important than number 7. Number 11, take a look over here. You can add one alternately, 2 and 4, okay, or alternate what? 2 minus 3 plus 4 minus, so these two numbers alternate is positive, right? 8, isn't it? The next one, two numbers is what? 3 and 3 is what? 6. Is okay? When you take off this one, when you subtract the difference, right? This is what? Divisible by 11, okay? Multiple by 11, that number is what? Multiple by 11. When you're over here, 2 plus 4 is 6, not 8, okay?
Okay.
And 3 plus 3 is 6. That difference is 0. 0 is what? Divisible by any numbers, right? 11,
Yeah.
okay? Yeah, that is 11. For example, we're gonna have a little big number. Let me check where is my calculator. Maybe 124 times 11. How much? This a little more, right? I'm gonna take off. Yeah. 1256 times 11 equals. I have these numbers. This number divisible by 11. We know that.
Yeah.
13,794. Right? This is, I multiply this one times 11.
Yeah.
And then this is what should be divided by 11. How can you check this one? That difference. 1, 2, 3. Alternate. How much is this one? 12, isn't it? This is how much? 3 plus 9 is what? 27. That difference is how much? Maybe you can use it, doesn't matter. Okay, or 27 minus 12, it doesn't matter. Okay. So how much is that? 137. That is not multiple over 11. Take a look.
Yeah.
13794. So 1 plus 7 plus 4 is how much? 12, right?
Yeah.
Oh my god. I done multiply this. Oh my god. Sorry about that. Add, okay. 3 plus 9 is what? Also 12. Oh my god, that is 0 mod 11, right? I'm gonna use the same
Yeah.
numbers. I'm gonna use different numbers. 120, 50, 6 times 11 is how much? 1, 3, okay. 1, 3, 8, 1, 6. So this number, this number, this number, total is how much? 15. This number is 4. The difference, 15 minus 4 is 11. Alright?
Okay.
This number 11 is 0 mod 11, isn't it? Or
Yeah.
4 minus 15, negative 11, also what? 0 mod 11, right?
Uh-huh.
Okay? So you have to memorize this one, okay? Alternate.
Okay.
Number 12 is what? This is divisible by 3 and 4. That's the rule. You don't have to divisible by 2, right? Or you
Yeah.
divisible by 3 and 4 means what? Sum of digits is what? Multiple 3 and the last 2 digits is what? Divisible by 4, okay?
Okay.
So we're gonna have some practice over here. Okay, number 1 over here, okay? We're gonna try number 1. Number 9, 8, 6 is multiple of 3. This is okay. This is multiple of 3 means what? The 0 mod 3, isn't it?
Yeah.
By the rule, what is the possible value of A? You can add all the digit number, right? So
17.
17, 6, 23 plus
So
A.
23 plus A is divisible by 3.
Yeah, that should be equals to what? Divisible by 3, right? 0
Yeah,
mod
so-
3, isn't it? This number is what is that? 2 mod 3, right?
Yeah.
Okay. So this number should be what is that? 1 mod 3, isn't it? So 2
Yeah.
plus 1 is 0 mod 3, right? Remainder is 3 equals remainder 0, isn't it?
Uh-huh.
So we're gonna find, okay, this number when divided by 3, 1 remainder. What is that? 1?
1, 4, and 7.
That's right. 7. The next, no. That's all because what? A is what? Only 1 to 9 number. Okay, so we have all
Okay.
3 possible numbers there. That is okay.
Yeah.
Now the next one, number 2. For what value of A and B, 12AB is multiple of 99. That is what? 0 mod 99. What is this? 99 is actually how much? 99, 9 times 11, right?
Yeah.
By the rule, it should be what? 0 mod 9, also 0 mod 11, isn't it?
Mm-hmm.
Okay, you can separate, right? Alright, we're gonna find this one. Okay, now let's find out. 0 mod 9 is what is that? Sum of all digits should be multiple of 9, right? So 1 plus 2 is what? 3 plus A plus B should be multiple of 9 is what? 0 mod 9. It's okay?
Okay.
Alright, the next one. That's the first one. Second one is divisible by 11 too. Right? Divisible
Yeah.
by 11 too. What is that? Alternate. 1 plus A, 2 plus B, alternate. You can switch, or it doesn't matter. So it's what? 1 plus A, minus 2 minus B, right? This
Yep.
should be what is that? 0 mod 11, isn't it?
Uh-huh.
You have 2 choices of here. Now we're going to solve this one. Simplify. Minus 3. So first term is what? A plus B equals negative 3 minus 3 minus 3. Okay? So mod 9. How to simplify? Positive remainder. A plus B equals what? Plus 9. Okay? 6
Yeah.
mod 9. You got this number. That's the 1 prime. Second prime, A minus B. A minus B minus 1 equals 0 mod 11. Minus 1 plus 1 plus 1. Finally, you got what? A minus b equals 1 mod 11. Right?
Yeah.
Alright, now let's find these numbers. A plus b is what? When you divide by 9, remainder is 6. What is all possible number? Because what? A plus b unit digit is what? From 0 to where? Up to where? 20, no, 19, right?
Yeah.
Okay, so a plus b can be what? 6 is okay. The next one plus 9 is what? 15 is okay. Right? Another plus and 2 more, too much. 24 is not working, right?
Yeah.
We got the only 2 possible variable, right? A plus b. A minus b, remainder is 1, what is that? It can be 1. The next one is what? Negative plus 11 is what is that? 12. It's okay?
Okay.
12 is divided by, but can you make a 12 over here? A minus a largest what digit is what? 9 minus 0 is what? Only 9. It can be difference is 12, right? Because there is digit number. Digit number is what? Max smallest one is 0, largest is 9. Okay, it can be make 12. It is okay? So
Yeah.
we have only one possible number over here. Alright, or maybe you can try negative 10. Okay, minus 11 is a negative 10. Can you make a negative 10? No way. Smallest one 0, largest 9 is 1. It can be negative 10. That's why not working too. Only one number is working. So we have like kind of like system of equation over here. Okay, so you can
Okay.
addition. So first one, so right, 6 and 1. 6 plus 1 is 7. 2a equals 7, but a is not integer. But that is nothing. A should be an integer number. Now try this one then. 15 and 1, okay? Plus
Okay.
2a equals 15 and 1 is what? 16. A equals to 8. Isn't it? That's fine.
Yeah.
What about b over here? A minus b is 7, b is 1, b equals what? 7, isn't it?
Yeah.
So this number should be equals, what is that? 1287. But a and b is what? That's the answer, okay? A is 7, b is a is 8, and b is 7, but the number is what? 1287. It is okay?
Okay.
Alright, that is what should be divisible by 99. Check it out. 99, 7, 9, 297, and divided by 3 one more time, 297. That is equal to 0. That's fine. Okay.
Yeah.
Okay, number 3. We have the number 19 factorial. Actually, this is 19 factorial. Looks like this is the same thing. 121, 6. They're gonna use the unknown number again. 625, 100, 40m, and 832, and 800. How many unknown numbers? 1, 2, and 3 numbers. So if you use a calculator, we can find the 3 numbers. Let me see. I have a right calculator. We are 19 factorial. 19. Where is factorial? Oh, no. 19. We're gonna go math. Factorial. How much? Wow. 1, 2, 1, 6, 4. Maybe we know that t is 4, right? The next one we don't know. Alright? Because the screen size is limited. So we can't. Anyway, this is what AMC cannot use, right? Calculator. Okay, now calculate out. Alright, how we solve it this way? The first last digit first. H is first. This one can be 0 and because 19 factorial we have right 3 multiple of 5, isn't it? Can you see that? 19 over 5 is what? 3. 19 over 25, nothing. We have a 3 multiple over 5. So right there, this one actually read that. It has a 5 cube number. Okay?
Yep.
Alright. So this is 5 cube means what? This number ends with what? 3 zeros. Is it okay? So we have a lot of 2 is what? A lot of 2. 1, 2, 5, 10, 0, another 0, another 0. So H equals 0, we know that. That's the first step. Now second step, wow, this is a long way. How can you find the number of t and the number of m? Wow. You can divide by 2? No, it's too much work. 3? Maybe possible, right? Or sum of all digit 3 is fine. But this number 19 has what? We have a 9 digit, also 3 digit also. But instead of this one, this also what? Divisible by 9, right? If we use what? Divisible by 9, we can narrow the searching area, right? If we divide by 3, a little more area, searching area, okay? 9 is a little small, okay? Now better use right, divisible by 9 first. Okay, 9 is possible, it's okay. This is we cannot use because this is already what multiple over what 8, right? The last digit is what 0, isn't it? This is always what this is working, but this is what we use instead of this. We're gonna use a 9. This is what divided by 4, right? Last 2 digits is 2, 0. 5 is okay. We use this one. It's no use, right?
Yeah.
To find what 2 unknown numbers. 6, 2, and 3. Always what 0 and 0 working. Okay, 8 is not working. 10 or not necessary. The only thing is maybe you can use right 7 or 11, only 2. But if you want to do 7, wow, we have a lot of work over here. Can you see that? Last digit is what? Times 2, subtract again. So times 2, subtract again. Wow, it should be too much work, right? But instead of that one, why you use what? This one. Multiple by 11, because what? Number 19 is what? We have prime number 11. This number should be divisible by 11, we know that. Right? But you can use division by 7, but it takes too much time. Anyway, we need what? One more variable. One more equation, okay? Alright.
Okay.
Now let's find digit 9 first. Sum of all this how much? 121, 1 plus, 2 plus, 1 plus, 6 plus, I'm going to use 5 of t plus, 5 plus, 1 plus, 0 nothing, another 4 plus, m plus, 8 plus, 3 plus, 2, h all 0. How much this one? Can you find out? Okay. How much this one? Plus 2 plus 3 plus 33, right?
Yeah.
Yeah, so that one will be t plus m plus 33. But this one should be multiple by 9, is 0 mod 9, okay? We got the one.
Okay.
The second one is this one, divisible by 11. Divisible by 11 is what is that? Alternately. You're going to add all this one. 1 plus, 1 plus, t plus, 1 plus, 0 plus, 0 plus, 8 plus, 2 plus, or 0 nothing. Can you add this one? 1 plus, 1 plus, t plus, 1 plus, 0 nothing, another 8, another 2. How much this one?
13 plus t.
13 plus, is it correct?
T.
Okay,
Yeah.
13 plus t. The next one, 2 plus 6 plus 5 plus 4 plus m plus 3. How much is this one? M plus 8, 13, 17, 20, right?
Yeah.
20 plus m. They are different. You can subtract. Each one, it doesn't matter, anything is first. 20 plus m, or we're going to use t plus m. I'm going to use this first. It doesn't matter, okay? T minus 13, okay, no, 13 plus t minus 20 minus m should be equal to what is that? 0 mod 11, isn't it?
Yeah.
Alright, now simplify. The first one is minus 33, right?
Uh-huh.
So from here, by modular operation is what? Minus 33, you can add, right, multiple of 9 times for 36 to make a positive remainder, right, smallest number. Okay, when you add this one, we got this one. T plus m, this number has the what? 3 mod 9, okay?
Uh-huh.
When you divide by 9, remainder is 3. Now t minus m over here. From here, t minus m and 13 minus 20 is negative 7, right?
Yeah.
That equals to 0 mod 11. But plus 7 plus 7 is what? 7 mod 11. So t minus m equals 7 mod 11. We got a final two equation over here. So now check it out. What is possible value of t plus n? T plus n, this is about 1 to 9, both 1 to 9. T is 1 to 9, m is 1 to 9. When you divide by 9, remainder 3 is what? This one should be what? 3. Or plus 9 is what? 12. Or plus 18 is too much. 18 plus 21, no, maximum number is 9. It can be more than or 18, right? So only two numbers available, 3 or 12. Now take out t minus m. T minus m is how much? 7 minus one number is 7. Yeah, it can be possible just 7, right?
Mm-hmm.
It's okay?
Yeah.
9 minus 2 is possible, right? What about the other one? Plus 11 is what? 18 is possible? Plus 11, 18 is possible? Subtract. 9 minus 9 is 18? No, right?
No. Yeah.
9 minus 0, only maximum is 9. That is not working. Now we're going to go the other way, because it can be this one. When you have a negative number, it can be negative number too. Minus 11 over here. It can be negative 4, it's possible, right?
Yeah.
You gotta be very careful. When you have a negative numbers, always we can make right negative remainder, right? Because one number is 1, the other one is what? 5. Still negative 5, isn't it? Negative 4, right?
Uh-huh.
Yeah, that is the remainder 5. So we have, right, 4 possible answers. So you can find the value of n. T first. 2t equals how much? 3 plus 7 is what? 10, isn't it?
Yeah.
So t equals to 5. What is the m? 3 plus 10. T equals 5, m is how much? Minus 2, right?
Mm-hmm.
Okay? But that is not working. Okay, m should be a positive integer, isn't it?
Yeah.
The next one. this is what you can try, but this is not working, right? 12 plus 7 is what? 19. When you divide by 2, that is not integer, right?
Mm-hmm.
So first we can try this one. This is not working. The next one is what? We can try this one. That is not working. Because what? 3 minus 7 is not divisible by 2, right? Now take this one. 12 and 4, try this one. 2 times t equals how much? 12 plus minus 4 is what? 8. Right? T equals how much? 4, isn't it?
Mm-hmm.
So when I will write down, okay. Replace it. T plus m is 12. T minus m is negative 4, right? Okay. When t is 4, what is m? M is 8. Isn't that working, right?
Yeah.
Okay, t is 4, m is 8, t is 4, m is 8. They're working. So here, finally, t is 4, m is 8. We just find, okay, t is 4, m is 8, h equals 0, right? We have 3 numbers.
Uh-huh.
Alright, so the question over here, sum of all these 3 digits, 4 plus 8 plus 0, which is what? 12 is the answer, okay?
Okay.
Alright. Okay, we cannot finish by subset today. Subset is very important. Actually, there are, in my books, there are 48 tips.
Okay.
Okay, we did up to number 36. Okay?
Yeah.
So 12 tips left because the book is updated right now. Okay, but it's gonna be published in October. Okay, because this month this is the summer is very busy to me, so I cannot make it publish in this month. So
Okay.
maybe after October, you can, if you want to continue the other 2 tips, you can buy the books. Okay.
Okay. Yeah.
And Amazon.com. And also, if you need help, okay, you can ask me. You can tell me. Okay, maybe
Okay.
3 or 4 times. I think that's enough. Or
Yeah.
2 or 3, okay, lessons. Okay. If
Okay.
you need me, you can email to me. Okay. But the
Okay.
book, all the book, I'm gonna put in there a little more tips. So if you wanna buy books, maybe I let you know. Maybe it's gonna be. Maybe I can make it right around the September.
All right.
Yeah. Some people they want to update the book before September. Okay. So
Okay.
you can buy the book after September. Okay. So we'll continue to work together. Okay.
Yeah.
All right. So thanks for joining the class. All right. So continue to work. Okay.
Uh-huh.
Also, you can go to our website. What is that? Art or problem solving. You can find all what is the AMC 12 questions there. Okay.
Okay.
So you
Yeah.
can try all, if possible, all of the questions one by one, from 1 to 25 questions. Okay. But some questions are very hard to understand. Sometimes, all right, the answer keys are so long. Okay, when I take a look, right, art of problem solving, the answer keys sometimes they solve that in very difficult way. Sometimes students they don't understand. Okay.
Okay.
So always we have to go to in the what is this shortcut, okay? Because actually there are 25, right? In the given time, 75 minutes. Impossible to finish 25 if we don't use any shortcut. Okay? Yeah, that's the problem. So just have a lot of practice. That is very important. Okay.
Okay.
All right. Sometimes if you don't understand the question, just mark it. Okay. Later, if we have a chance to work out together, we can try that questions. Okay.
Okay.
All
Yeah.
right. Thank you so much today. So I'll see you next time. Okay.
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 Yeah.
Thank you.
Thank you.
Okay. I'll send out the video. Maybe it takes around 2 hours. Okay.
Okay. Yeah.
Okay. Thank you.
Thank you.
Bye.
Bye.